Thank you to be here, and I'm happy to see that much people here. Also the sponsors, thank you to make possible this event, and yeah, we are part of. My name is Rombouts. I'm working for Redwire Space in Kruibeke. I'm the security assurance manager there and the export control officer. I do a lot more, but this is the main focus what I'm doing. So what is the goal of the function? I'm busy with physical security, with cybersecurity, and with the security in the projects. So who is Redwire Space? We are making satellites and space instruments. That's what we are doing. Okay, wait, I have to switch here. Wait. Okay, space is one of the fastest growing sectors nowadays. Everything in today's world exists within or is connected into space, meaning we must address cybersecurity as a top priority. Cyber attacks may compromise the functionality of satellites, and this impacts not only the military, where it in fact comes from. Satellites are more present in our daily life. Think about fleet management, banking applications, energy grids, communication, internet, navigation, and so on, broadcasting, all what you can think is connected to space. The unique operating environment, the distance factor, because it's far away, and the complex architecture of space, ground, and optical and of RF interfaces makes it a potential vulnerable interface. This means that access to any communication of one of these interfaces is the start of a possible cyber attack. Do it like this, yeah. So here I will give you some examples of recent satellite attacks, mainly by the following components: jamming, spoofing, or disabling GPS communications. So the multi-domain attack on Viasat, disrupting the satellite connectivity in Europe via an internet-connected VPN appliance, was happening in 2022 while the war in Ukraine broke out. So this was disrupting the communication here in Europe, and you see here all the access points on the figure that were involved. Another attack was the 12-day war in June 25 between Israel and Iran. Nobody has heard about it, but it happened really. 72 space cyber attacks occurred, mainly DDoS attacks, data leaks and data breaches. Who was involved? The Israeli Space Agency, 2 Israeli defense companies, and NASA. To protect us against data intercept monitoring, data corruption, and seizure of control, we need to do more than the basic stuff that we know in cybersecurity. So why is cybersecurity in space so critical today? As I said, we are using a lot of services that we don't know or don't see physically on our phone. Yeah, you are watching a movie on YouTube. That's quite possible that it is transferred or sent to your mobile phone via a satellite. And that's why the space sector is included in the NIS2 directive, imposing stricter cybersecurity requirements. We as a company, we need to be NIS2 compliant as well, because we will perform ground station activities. Suppose you want to go from point A to B, where you have never been before. What you will use? Right, your mobile phone or your car using GPS. And this is data produced in the space. Due to the importance of the space sector, it makes it a prime target for cyber threats and attacks. We want to explain some key high-risk space cyber threats: jamming and spoofing. Satellites use different frequency bands. Using signals to block or to spoof communications lead to fraudulent data and signal interception. For your information, the amateurs here, below 6 gigahertz, it's a game to just listening to all satellite communication and to try to decode them. The satellite hijacking and command infiltration. The unauthorized access to satellites and to the command of and control, the C2 like we say, allow hackers to take control of satellites. Ransomware, the introduction of malicious code into software, even in the company or outside, to the satellites, can disrupt operation. The data exfiltration. They know what you know. That's very clear, it's very simple. An insider threat, I was telling it already, so malicious actions by personnel that have access, authorized access to sensitive space data and mission data. This is really a very hard topic for me as a security assurance manager. And then the nation-state attacks, it's a real concern for the Russians, the Iranians, the Chinese, and so on. So these are the, like we say in Flemish, the schurkenstaten. So they are very hard in jamming and spoofing of satellites. So the risk of sophisticated and disruptive threats grow. It's up to the industry to uplift the security in space. When things go wrong in space, in orbit, we can't send out a physical person to do a repair, or there is zero physical access to the satellite. So that's the big problem we have. So we are facing special challenges like the distance, the delay, and the high cost of assets, which turn every second into a critical window to prevent mission failures or even the loss of the satellite. Because of the latency, we can't physically patch satellites that are facing bit flipping due to radiation. This is also something we have to take into account. This means that, based on these examples, conventional incident response, as we know here on ground, are not applicable anymore in space. So we have to have other techniques to work towards a satellite in case something happens. An update of the firmware on satellites is a gamble. A failed push can break vital infrastructure links as well. So, and then we lose the satellite. Just for your information, there are 4 distinct segments and what to protect in space. I speak here about 4. Sometimes we have 5 and even 6 segments. But I will explain the most important ones. The space segment. This is including the satellites and other space vehicles above 100 kilometers above Earth. What are we protecting there? The onboard computers. So in a satellite, there are onboard computers, even redundant, to make sure that we have a lot of reliability. We protect the software from malware, the unauthorized access, and we prevent hijacking and spoofing. And we ensure the secure firmware and software updates. How we will do this? We will have armored shielding of the satellite. I don't know if you have ever the chance to visit us. A couple of years ago, we had an open door, and there you could see the last launched satellites in the clean room. And they are completely packed, because in space there is a lot of radiation, what creates a lot of problems to the hardware, to electronics. Encryption, we use encryption as well, and secure command links. The ground segment is everything on Earth. General infrastructure where people, hardware, networks, and physical locations are. And this is the most challenging segment, as it is an interesting target for cyber attacks. What are we protecting there? The telecommand and telemetry. So telecommand is the commands to the satellites. Telemetry is the health of the satellite, all the information, the position and so on, that is coming back to Earth. How we do this? This is a layered security of encryption. So we have building blocks in the satellites, and all these are, the communications between the building blocks are encrypted and protected. We protect also the authentication of the data to maintain the integrity. How we are doing this? By strong encryption, zero trust network access, this is a term that we know here on Earth very well, and the continuous monitoring for threats. I will explain this in the next part of the presentation. The link segment, and then I have again a question. Do you think most of the space signals are encrypted? You're right. No. Why? Due to older technology, or not needed for data coming from weather satellites, or environmental situations like high radiation bit flipping, as I mentioned already. And there is a certain area on Earth where this is a very high radiation. And this is the South Atlantic anomaly, they name it. Sorry. So the communication link is between ground and space. Mainly, as I said, RF links and optical links introducing enhanced security by design. And that's the topic of the second part that Stijn normally will give, but I will do that now. What are we protecting in the link segment? The encryption of the telemetry, tracking and control. And we prevent jamming and spoofing, and even eavesdropping on communications. How we are doing this? Thanks to encryption, authentication protocols and secure protocols. Then we have the user segment. User segment is all user electronics, like your mobile phone, like a car, all other things that you're using, where you get data from satellites. Where we protect the secure communication link, we prevent unauthorized access, and we ensure the data integrity. How we are doing this? Again, encryption, secure protocols, and authentication. In case the customer is asking to store the satellite data in the cloud environment, which is possible today, we have also a cloud segment, but I will not go into detail right now on this topic. What is the attack surface in space? I made it visible here. As you know, there are a lot of satellites in orbit. How many do you think, how many satellites are in orbit at the moment? 40,000? 14, that's correct. Yeah, that's correct. That's correct. And as you see that other space manufacturers are or will launch like 2,600 satellites, yeah, for the next coming year. So this figure is growing a lot. So a successful space attack requires four main components. That's the access to the space satellite, to the vulnerability, yeah, like we know here on Earth, a malicious payload, and the command and control system. The potential cyber attack vectors are in the space segment. The target, the communication, the control and the coordination system. In the ground segment, who are still hackable and are the easiest way to hack or to attack, providing direct access to the command and control of the satellite to take over the satellites. The link segment, so it are intermittent communication links between space and ground and relies on RF or other interfaces. And the user segment, unauthorized access, compromising service integrity and confidentiality. In the supply chain, also very important or becoming very important here, and nowadays, even in this too, this is a requirement. In ISO 27001, it's a requirement. In the CRA, it's a requirement. So all these together, all these standards together, yeah, we have to be compliant with. And supply chain management is a very important factor there. Why? Because we don't want to have backdoors in our hardware or in the software. We are working together with other companies, writing the software or delivering the software. We don't want this, so we have to check this. So during manufacturing, we have to have a look at this. Yeah, we have to know what our partners are doing. But not only in the development phase, also the security in the launch and the deployment process is important. Something that we have to take into account as well. How do we hard the satellite cybersecurity? So we are thinking a lot far ahead. Yeah, we are doing a development, but we must think ahead. And we need a secure by design approach, as the new cyber standards are asking more and more. So we embed cybersecurity in all phases of a space project, so from development to decommissioning. Even at decommissioning, we are taking this into account, cybersecurity. A major challenge that we have is to establish a trusted control. Like I said, the ground segments is one of the most important ones that are attackable directly here on ground. And we have to control who can command what across the space and the ground segment, relying on the communication links. Data in space must be available on those who need it, uninterrupted, anytime, transferred and stored securely. And that's why we use up-to-date frameworks, like I have listed here some frameworks and standards, which provide guidelines to keep space systems consistent and more secure across borders. That's the first part. I will now switch to the other presentation. Sorry for that. Sorry, the presentation is not in the format that you were expecting, but okay. What has Redwire done in the past? Redwire has 5 satellites in orbit. Proba 1, Proba 2, Proba V, and Proba 3. Where is number 4? You don't know? Well, Proba 3 was, in fact, the launch of 2 satellites. If you have seen the launch in December 2024, where 2 satellites were launched, one satellite is used to make a shadow on the other satellite to study the corona of the sun. Yeah, that's the goal of the 2 satellites, flying information in space, 144 meters distance from each other. These satellites were launched respectively in 2001, 2009, 2013 and 2024, as I said. So the design phase of such a satellite starts mainly 3 to 5 years in advance. That makes that the technology is already outdated that we are using, yeah? Certainly for the platform. So the platform is the satellite itself, yeah, but less applicable for the payload. A payload is, for example, a camera to study the corona of the sun or to study the vegetation of the Earth. That's the Proba V, the V from vegetation, yeah, or Earth observation, which are the other 2 satellites, Proba 1 and Proba 2. So reliability is more important than performance and security due to the long-term mission. That's the idea of the customers. Oops. Okay. We are not making satellites for our own. So we have a customer, ESA, yeah, and ESA is choosing the satellite prime contractor, which we were lucky, we were the prime contractor for all these satellites. And ESA is also the final owner and the operator. And ESA determines the security in the satellite. So we cannot change that. We cannot say, look, this must be more secure. No, ESA says, these are the specs you'll have to follow. And this is the thing that you have to develop and to produce and to launch, point. So to communicate with satellites, in the past, this was a high initial cost in the past. Such an antenna cost a lot of money. Modems, amplifiers, it's because the long distance, it's not a normal amplifier that you are using, a special developed material and so on. Mainly as well if it comes or there are parts coming from the US, you have the export control regulation and so on and so on. So all these things together, yeah, make that communication in the past was already a difficult thing. But there is a very low risk for cyber attacks towards satellites. That was the meaning of ESA in the past. Security was not a priority. But last year I was visiting CISAT in Paris. It's a yearly exhibition for cybersecurity in space. And for ESA, security was a top priority, or is a top priority. So things are changing. In addition, it's very expensive to implement good authentication and encryption in satellites because it's all, it's not standardized. Huh? It's a development that you are thinking how we make things secure. So we have guidelines, but we are modifying the final development for security reasons. So I cannot disclose any information about this, but this means that a high level of security is implemented for specific missions. As for example, the Galileo. You know the Galileo, that's the European navigation satellite. And more recently, last year, also for the Sentinel-5A, the satellite that was launched for Earth observation. Usually, in science missions, there is no security or a light security included in the satellites. Oops. So, a difficult thing is to choose between reliability versus security. That's the customer who is deciding that. So we have a special satellite operating mode. We name it the clear mode. So we are able to send special commands to satellites. Yeah. You can think how this works. I will not go into detail, but you can think how this works. There are certain backdoors based on this safe mode. Yeah. Because then a consequence can be that the satellite can become unusable. So what is the danger of open science satellites? ESA missions make science public anyway. So if you look at the internet, you can search all these things. And the biggest threat is to make a satellite unusable. Or you can use satellite collisions. That could happen, but this is technically extremely difficult. In the meantime, it gets much easier for attackers. The price of devices is very low and available. As I said, for €300, you can have an antenna and an SDR to listen to satellite data and try to decode them. Here you see a picture from a forum, Tech45. It's coming from a weather satellite, so you can view this online. That's not a problem. That's available for everybody. Due to the outdated and difficult to update space segment, ESA has chosen to invest in the high-level security of ground stations. They receive all the data from the satellites, the interfaces, the modems, the frequencies, the modulation types, the coding, the session keys, master keys, everything to protect your data. These ground stations are needed to send commands to a satellite and receive the information that is also processed in the satellite and coming back to Earth, and for the telecommand and telemetry data. So the physical security of the ground stations is a high priority. I explained already how this is done, so we have a lot of things that we are investing in network security. And here you see a picture, who knows it? This is the picture of REDU in Belgium, the aerospace REDU Space Center in Wallonia, in the Ardennes. So this is from ESA. REDU has also a cybersecurity test center built recently. So they have the Security Cyber Center of Excellence and the Cyber Safety and Security Operations Center. Belgian companies are playing a big role in this to make this happen. And something to be proud of what we have in Belgium. This is rather unique in Europe. For example, the launch of the Proba 3 satellites was completely controlled in REDU by the operations team of Redwire. Here you see a quantum computer. Why better security is needed in space and also applicable in space. So quantum computers will break the traditional encryption standards, as you know already. We are busy with post-quantum communication and encryption, and they have the possibility to decrypt sensitive information. So we usually use a typical asymmetric encryption using a public and a private key. This is not considered as post-quantum secure. So we are looking for post-quantum safe algorithms. And here you see an example. You have Alice and you have Bob, and you will share the same symmetric key to Alice and to Bob. But the big question is, how do you get these keys to Alice and Bob? And therefore we use quantum key distribution. How does this work? So a random generated key communicated to Bob via quantum features of photons. QKD enables users immediately to detect eavesdropping attempts. Why? Because reading photons is changing the state of the photons, which result in data errors. And if this error rate is higher than a certain threshold, the receiver knows that the key is compromised. These data errors are detected by Bob, and this QKD is a proven effectiveness and is 100% safe. This is statistically based. This you can use on Earth with a distance of 200 kilometers, and in lab it's more than 1,000 kilometers, but this is not in practice used. So how we will do this? So we are proud to say that we are having a project, together with ESA and with Honeywell, a QKD-SAT project, where we are working on, and in space we are facing bigger distances, and this project makes it possible to overcome this limit. We have usually two methods, entanglement and the QKD protocol. Here, and this is a way, the QKD protocol, we name it the sequential rendezvous, which is more flexible as the satellite will store the random keys. The satellite has also the keys on board, which is a security issue. And it's possible to transfer these keys to the second user at the other side of the world. That's high level how it can be explained. I cannot go into details. I cannot disclose any more data about this. If you want, have a look at internet to know more about quantum key distribution. There is the general protocols are explained there, but for security reasons, I cannot disclose more about this protocol. Here you see a picture of people of Redwire, or Minister President of Flanders, people of ESA, and the people of Honeywell when the contract was signed. So we are proud to be in that project. And one thing that I have to mention here is that the security measures also in this type of projects to attack a satellite from orbit is that means that if that happens, the keys must be destroyed. The master keys and the session keys must be destroyed. Otherwise, if they have this information, they can communicate again to other parties. That's something we want to prevent. So this is a typical technique, like, for example, if an F-16 or an F-35 crashes, also there in that airplane, certain devices are destroyed automatically. So feel free to contact us if you need QKD-SAT communications in the future. We are working on it. I'm quite sure this question will come. Voilà. That was what I wanted to present, to give you a better idea of cybersecurity in space. I hope this will help you a bit. And so we are facing a lot of challenges on Earth and in space, which we have to overcome. And that's what we are working on to protect you.